Welcome to Spring LIB.
Hi, so this problem is actually derived from the previous problem which we have solved, but I will just draw it here quickly. So this is the rod and it's sitting on an inclined plane. The distance of top of the rod from the ground is 300 millimeters in vertical direction, 125 millimeters in horizontal direction. Length of the rod is 500 millimeters. And this is point A, this is point B. Let's call this point C. And this time we are given the angular velocity, which is 4.2 radian per second, and we are asked what is VA and what is VB. So all these problems proceeds through similar steps. So step one is break this into translation and rotation. So to do that, this is our rod. Let us assume that VA is moving with some speed VA here. So if this is VA, this will also be VA, because for a rigid body, all points move with the same velocity. Now, since we are using the velocity of A, let's put A fixed for the rotational part, and omega is already given to us, and the rod will fall down. So omega will be in this direction, and VR will be always perpendicular because VR is omega cross R. So it will always be perpendicular, but it will point like this because the rod is falling down. So now we need to add VR and VA to get the net velocity, and we do that for step 2. This is break velocities along perpendicular and parallel to motion. So motion in this case will be along the wall. So we have to do it parallel and perpendicular to the wall. So again, we have to be careful in drawing these things. So this is our wall. This is where the motion is going to be. And we know that VA is like this, and this theta we have calculated in previous problem. So this angle is going to be theta. So then calculating VA components is easy. Then comes the rod. This is the rod, and VR is perpendicular to the rod. So this is VR. So now we need this angle. So this angle or this angle, any of them will work. So in the previous problem, if we assume this angle to be phi, this angle will be theta minus phi, because exterior angle of a triangle is basically the sum of interior angles. So phi plus theta minus phi is equals to theta. So this is theta minus phi. And since this is 90, this angle is going to be 90 degree minus theta minus phi. So now we know the angle of BR from one of the wall. So we can calculate the components along and perpendicular to the wall. So now we have everything. So we just write the equations. So this is, let's write perpendicular to the wall. So perpendicular components. So VR, this will be sine of 90 degree minus theta minus phi, because this angle is 90 degree minus theta minus phi. So this will be cosine, this will be sine. So this has to equal the perpendicular component V of VA, because VA is, because there is no net motion along perpendicular to the wall. The motion is only along the wall. So perpendicular to the wall, VR sine 90 minus theta minus phi has to equal VA sine theta, so that there is no net motion. So this gives us VR, this will become cosine of theta minus phi. This will be VA sine theta. Cosine of theta minus phi is VR cos theta cos phi plus sine theta sine phi. And this is VA sine theta. VR we know, have we calculated VR? So VR is just going to be omega L sine 90. So omega is 4.2 radians per second. Length is half a meter, 500 millimeters. So this will be 2.1 meters per second. So And theta and phi, we have calculated all these values in the previous problem. So please refer to the previous problem if you want the exact values. So VA is 1 over sine theta, and sine theta was 12 over 13. So 1 over sine theta will be 13 over 12 times cos theta was 5 over 13, cos phi was 4 over 5, plus sine theta was 12 over 13, and sine phi was 3 over 5. So this times 2.1 meters per second. So 13 will cancel everything inside, and then we eventually get 20 plus 36, 56 over 5 times 12. So 56 over 5 times 12 in the denominator, then times 2.1. So we can calculate these numbers. So 56 and 12 can be further simplified because 4 divides both of them. So I think it's 4 threes are 12, 4 14s are 56. Then this becomes 14 ones is 14, 14 twos are 28 plus 1 29, and then 5 threes are 15. So this gives us 0.1. So 15, then 14 and 4. So 15 nines are 135. Then you are left with 9 and then 6. So this much meter per second is our VA. Okay. Then what about VB? So VB is going to come from the most components along the wall. So components along the walls are VA cosine theta plus VR cosine of 90 degree minus theta minus phi. So this is VA cos theta plus VR sine of theta minus phi, which is VA cos theta plus VR sine theta minus phi can be again written as sine theta cos phi minus cos theta sine phi. And we calculated all these values in previous problem. Please refer to that. So eventually we get VA cos theta is cos theta was 5 over 13 plus VR sine theta was 12 over 13, cos phi was 4 over 5 minus cos theta was 5 over 13, sine phi was 3 over 5. So this gives us, so VA is 0.196 times 5 over 13. This is meter per second, plus VR was 2.1 meters per second time divided by, so 13 fives are 65, and then this is 12 fours are 48 minus 15. So this is 33, and then denominator is 65. Yeah. So if you calculate these numbers, so I think now they are somewhat complicated, so I'll just use a calculator. So the first but this I can do by hand. So 5 6 are 30, 5 nines are 45 plus 3 48, 5 ones is 5 plus 4 is 9, and decimal point after 3 digits, so 0.980 by 13 meter per second, and this gives me 13, can divide this, so 0.791 70, 13 threes are 69, so I think this is 0.73 meter per second, and then sorry, this is not 7.7, and then after 7 did the, let's divide this again, so 0.13 sevens are 91, so 7 is remainder and 0, so 70, so then 13 fives are 65, so this will be 0.75, and then you are left with a remainder of 5 0, and then 13 fours are 42, so 0.754, so we'll just leave it here, 0.75 meter per second, and then there will be another decimal, so there will be 0 here, 0.075 plus, what is this number? This will just use a calculator, so 2.1 times 33 divided by 65. So 2.1 multiplied by 33 divided by 65. This is 1.067. So 1.07, let's say 1.07 meters per second. So in total, we will get 1.145 meters per second, close to this number. So this is our VB. So this is how you can solve these problems. Just break things into translation and rotational, break the velocities, and the third step was basically here when we are comparing the perpendicular component and comparing the parallel component. So you do this and you can solve all these kind of problems. Thank you.